Okay, thank you. Thanks for the confirmation. So we'll start another 30 seconds from now. Let me share my uh, desktop with you, and then of course we can start. So share here. So here we are, and you should be able to see my desktop now. And let me show you the PPT first. Right.
Morning, sir.
Yeah, good evening, everyone.
Good
All
evening.
right, so let's get started. It is 7 p.m. now, and we can start now. So first, of course, is why are we learning R? And I'll be very brief here because we don't have much time for R. So R, this is for beginners and biologists, and this is Steve Jobs, and Steve Jobs says, uh, cancel, okay. And Steve Jobs says everybody in this country should learn to program a computer because it teaches you how to think, right? And this is Jack Dorsey, who's the co-founder of Twitter, and he says code teaches you how to face really big problems. So coding is something that is more of a discipline, more of a hobby, more of a, it's kind of very intoxicating when you start coding. And as of today, it is really important because biology is now fast moving into a data-driven science. So you have a lot of data that is generated through high throughput machines. And because it is not manually possible to analyze this data, you anyways have to, at some point of time, shift to programming and do the data analysis, not manually, but computationally. So therefore, it becomes important that you learn a bit of programming. Every researcher should now know programming. And of course, the flavor of the season as of now is Python and R, right? And Python and R together form a very formidable combination of programming languages that can literally perform any task that is given to you. So therefore, both Python and R become equally important. R is more of a statistically driven language. Python is a more general purpose language. But the syntax and the way both work is almost similar, right? So let's move on. So R is a programming language. I've already told you. It is a language and environment for statistical computing and graphics. And then it comes also with what is known as an integrated development environment. So for beginners who want to know how to use R, there is a kind of a help that is provided in the terms of integrated development environment, which is basically a mouse based or a cursor based system where you can load a file, you can do many programs on mouse click and everything. So many actions can be performed on mouse click. So that helps you basically ease the learning curve a bit. So R Studio is an integrated development environment, or IDE. It is called an IDE for R. It includes a console, syntax highlighting editor that supports direct code execution, as well as tools for plotting, history, debugging, and workspace management. And we'll get into R Studio and we'll see how this works out, right? So we'll get there in a moment from now. Just to finish this part of the talk. So here you are. Why R is a question that one needs to answer. So whenever you're learning something, you must know why are you doing it. So here is an important answers to why you are learning R. First, R is a statistical package developed by statisticians in the field. So it is more accurate, more correct than any other statistical package that you may be using. You may argue that there are other statistical packages also available. Yes, there is MATLAB, there is SPSS and others, but they are all paid. R is open source, free for academic users and other users as well. So this is important that R is open source, it is free. You can also contribute to development of R and you can use all the tools available in R for free by downloading and loading into your local systems, right? So, and R has a huge community that contributes to its environment. So therefore, it's a dynamic environment. You have every day a new tool coming up, a new pipeline coming up for biological data analysis. So therefore, again, this is more dynamic as compared to others. Then, as I told, there are, apart from base package of R that you'll get when you install R, you'll also have a lot of libraries that are not available with R directly, but can be downloaded into R. So you have a large variety of specialized libraries. These libraries support and enhance the R development environment, so therefore it becomes important. Then it also has a graphic user interface, called as integrated development environment. And this is basically eases the learning curve and makes it a lot easier to learn R as compared to other languages where I could directly go to an editor and then go to a terminal to run the part and everything. So that is again something that is an advantage with R. Then R has cross-platform support. It is machine independent. It can work on any type of machine and any type of operating system, right? Then R can do data cleansing, data wrangling, and web scraping. So you can download data from the web. You could clean the data, do a quality control of the data. You could also change the format of the data from, let's say, short format to long format and so on and so forth, because many a times in your analysis, you would see that the output of one pipeline would be the input to the next pipeline. However, the format has to be slightly modified. So that can also be done in R. So that is what is data wrangling, and we'll have a look at it as we go along. Then another important USP of R is that you have what is known as quality graphics. The industry standard today is ggplot2, which is a package in R, where you can make very high quality and high informative visualization of the data. And again, because the data is high throughput and huge, data visualization again becomes very important again, right? So therefore, R has scores very high on this point as well. ggplot2 is the current gold standard for graphics. Then it is compatible with other programming languages and like C, C++, Fortran, Net, Python, etc. And then it is compatible to high performance computing and big data analytics. So I've given you enough points to tell you why R is important to you. First and foremost, it is a statistical package, so therefore it is important. And then of course, there are other things that make it a very valuable tool or valuable skill in your kitty. Everybody with me, class? Everyone listening? Okay.
Yes, sir.
Okay.
It's very interesting
Yeah.
class.
Okay. Then we move on, and of course, not everything can be taught in limited time of the workshop. So we have 2 lectures for hour. I'll try and cover the maximum, but of course, in my effort to cover the maximum, it should not be that we don't follow. So we'll go slow, we'll go steady. And of course, a lot will depend on how much you follow up after this, right? And in case we're not able to cover up enough, you can go to my YouTube channel, and there I have these R videos loaded. You can have a look at them there as well. So you will not become an expert at R after attending this workshop because it is just 2 days per hour. It may not be enough. I mean, you will become an expert over 6 months, 1 year when you regularly do it every day. Remember, programming is about moving your fingers. It will not come by watching the screen, or it will not come by seeing others run their program. You have to type the program. Remember, typing is important, right? You have to type a program, then only you'll learn. But of course, you'll get a fair idea of R and whether you are compatible with R. Not everybody is compatible with programming, so that is another issue. If you're not very comfortable, there are other ways of doing things, right? There is Galaxy that can do many of the things that you can do in R and Python as well. Then learning will come when you have a real problem in hand. Persistence and regular practice will make the learning curve a lot easier for you. A lot of online discussion forums, YouTube videos will come in handy if you want to make a sincere effort to learn, and including my videos as well, right? So so R comes in 2 versions. One is the command line version. So when you download R into your system, whether it is Mac or Windows, you will have this kind of when you go to the terminal, you'll get and write R. You should get this kind of message which says R version XYZ, and so on and so forth. And then from here on, from the prompt, you can start your R, or you can write your scripts. Then the other easy way, which we'll do today, is what is known as the R Studio, right? And R Studio comes with 4 frame here. There will be 4 windows, and each window will have a particular setup. We'll come to it, and I'll show you how it works in a moment from now, right? So I think we can start from here, and then we can take it forward. So let us now do with the introduction and move on to R, right? So let me just show you. So first, of course, is installation. So I'm sure all of you would know, but just to show you, you can download. So this is for installation of R on your system first. So first you have to download the actual R, and then R Studio will integrate into the R that you've downloaded. So this is you can go to CRAN, Comprehensive R Archive Network.R-project.org. And from here, you can download and install R depending on whatever system you have. If you have Linux, Debian, Fedora, Red Hat, Ubuntu, some of you may have Ubuntu. If you have Mac operating system or Windows, you accordingly click and download and click on execute, and it will basically install R into your system. Once you've done that, next you are download your R Studio. To download R Studio, you have to go to rstudio.com, products, R Studio, download. And here you have several versions, one of which is free. So R Studio Desktop is free. This is what you have to download. You can download this, and that should become a easy thing for you to do, right? And it has all the basic utilities that we require for our purpose as a beginner, right? So then we move on and we talk more about, so I'm sure you'll be able to install. There is not much of a problem. In case you have some problem, again, YouTube videos will come in handy. It is ideally not a problem. It is simple download and then click on the executable file and it will install your RStudio by just clicking on next, 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 and I agree at max, right? So then we move on and we come to RStudio now. Right? So when you open your RStudio, this is your default how it would look, right? So you'll have 4 panels here, 1, 2, 3, and 4. And in my case, I have basically made the console come up here. So let me just show you the default look here. So default will be console on left. So when you open your system, it will be like this, right? So this one here is what is known as the scripting area, where you can start writing your script, right? So you could write whatever you want to. Let's say you say 2 plus 5, right? So this is your first code that you're writing, and you say run. And on the console, you'll get the result along with whatever instruction you had first written, right? So this is the console. And default console will be at the bottom of the scripting area, right? And then because you want to, when you close the system, everything will be lost. So if you want to retain this script that you're writing here, you can say file and you can save as, and then you can save as .r file. And then of course you can load it again and run it again. So we'll come to it in a moment. Just to give you an idea, this is the scripting area where you can write your script, save it with some name. Usually R files will have a .r extension so that you also remember and system also understands easily this is an R file. And then of course, you can, anytime when you want to rerun your program, you can reload from here, file, you can go to open, and then you can go back to search menu and load a file. For example, here, let's say I'm loading this file. So ggplot1, right? So here is my ggplot1 now, right? So this is my another file. So let me just close this and come back here. So this one is what you have here. Then let's say you also have this panel here. This is what is known as the environment panel. Environment panel, whatever variable you allow here will be displayed here, and we'll come to it as an example in a later a few moments from now. And then this one is your last panel. Here you can see there are several tabs. You have files, plots, packages, help, viewer, presentation. So this is basically multiple, depending on whatever you require. You can, if you're making a plot here, the plot will be displayed in this tab. If you want to load a package, you can go to this packages tab, and then you can, if you want to install a new package, you can click on install, and then it will come to your CRAN repository. And from here, you can, let's say you want to install a library called ggplot2. It will come up here. You can select from here, and then you can say install. So these are basically, as I told you, R comes with a base package where certain base functions are already given to you. But some of these libraries are not in the base package. You have to load them from outside. So these are again present in the comprehensive archive network. Do not come with base package, but you can have an add-on, right? So it's like you take your you take a car and then you buy its cover and all the extra lighting that you want to do with your car. So that's like that. And some of these libraries are really useful. As I told you, ggplot2 is the industry standard now for graphics. Everyone with me, class? You following?
Yes, sir.
Yes, sir.
Four environments are there.
Yes.
Sorry?
4 types of windows are in this RStudio.
Yeah. So I'll just tell you one more time. This one here is for scripting, where you can write your script. And I've shown you how you can write your script or load your script from here. So you can go to file, you can go to open file, you can load your pre-written script here. Let's say this time I say meths code, right? So here is my meths code getting loaded here. So this is my script that is getting loaded here. So this is a pre-written script that I've loaded here. Let's close this now. This one here is the console. So whatever input you give here and when you run, the output will be shown on the console, right? So this is your standard output. Basically, it's your console. Then this one here is your environment variable where you can see your environment. You can also see the history. You can also see connections and tutorials where you will not really go here. Mostly you'll be in the environment variable. So whatever variable you declare here will be shown here. And I'll come to it in a moment. I'll show you more of it. And this one is multiple tabs where you can have your files, plots, packages. So whatever, depending on what utility you want, you can click on that tab and take that utility forward. I showed you how you can install a ggplot2 library here just now, right? So now let's get on with the basics of R. So first we talk about the data types in R. What is the data type? Individual data element, what type it belongs to is basically what is the data type. So let's get started with first data type, and then we'll come back here and talk more about it. So I've written a script already for you so that we have less, so that we save time. Every time you load your RStudio, it is a good practice to first clear out the buffer. So this brush here will help you clear out the buffer. So I can click on this brush. So now you see my console is absolutely clean. Likewise, I can click on this brush here and I can clear out my buffer here as well, right? So I normally keep my console on the right-hand side. So, but for now it is okay. So here you are. First, we'll talk of the data types in R. So there are 6 data types in R. A singular data, what is its nature is what is known as the data type, right? So there are 6 basic data types in R. 1, numeric. 2nd, integer. 3rd, character. 4th, logical. 5th, complex. And 6th, raw, of which raw is something that we'll never use. Complex also will use very infrequently. But these 4, numeric, integer, character, and logical, is something that we'll use very commonly. So therefore, these four have to be understood in full context. So for example, I say A equals to 23.5, right? So now I run this part. So I've highlighted the line I want to run and I run this. And immediately you see here in the environment variable, you have A and its value is shown here as 23.5. So any variable you declare here, its value will be shown here along with the name of the variable. So that is the important part that environment shows you. Now we want to see what is the class of A. So this is a numeric. So you say class of A and you get your answer in the console. This is numeric, right? Then if you want to declare an integer, then integer has to be declared with a suffix capital L, right? So if you say A equals to 23L, this is an integer. How do you say this is integer? You check for the class of A. So first you run this part, right? We can run both together. So you run this and you can see A is an integer now because A has been equated to 23L, where L indicates that this numeric that you're giving is an integer, right? Then A equals to DNA, the next one. So this is a character, right? So this is a character. So when you run this and check for class of A, you will be able to see what is the class. The class would be character here. Here you are, this is character, right? So I told you there are 6 data types in R. 1 is numeric, 2nd is integer, 3rd is character, 4th is logical, right? So when you say A equals to true, so this is basically can only have 2 types of values, true or false. You say A equals to true and you run it. And then you say what is the class of A? It will come as logical or Boolean, right? The other word for this is Boolean. And then you have A equals to 2 plus 10i. So this is typically y equals to mx plus c kind of situation here. So this is a complex where you're adding an imaginary number. So this is a complex number. So if you run this and then you select the class of A now, so this would be complex, right? So this is complex. And then you have the last one, which is called the raw. So which is basically, I'm trying to see what is the hello in ASCII letters in raw state. So you say A equals to char to raw, and here you write hello, and this would give you how is it represented in ASCII and in actual memory state. So you say here, and this is the value of A in raw 48, 65, 60, 66F. You don't have to go into the details of this. If you just check the class of A, this will be raw. You will hardly use it at any point of time, right? So this is basically to tell you that there are 6 data types in R. What is the data type? The nature of individual data point, one single data point, whether it is numeric, integer, character, logical, complex, or raw is what is known as a data type. Now, data types are individual data is not what we're looking at. We're looking at a collection of data. The data can be organized in several ways in R. The first and the most simplest type of way in which the data can be organized is what is known as a vector. So we come to now data structures. So the way the data is organized gives you what is known as a data structure. So we now come to data structures, and in data structures, the simplest data structure is what is known as a vector, right? So here I say marks equal to C, and then I give marks in 7 different subjects, right? So this is a vector, right? So the simplest way of declaring, sorry, the simplest way of creating a vector is to use the C function. C is for combine or concatenate, right? So you say marks equal to combine, and then you give 7 different marks in 7 different subjects in double round brackets, right? In round brackets. So this is your vector. The vector name is marks, and it has now a collection of data points. Each of these is numeric, and this is 85, 88, 90, 76, 88, 80, 87. So you can say print marks. So when you say print marks, you'll get the values in marks. So you say run, and here you are, because I've not run the first part. So let me run the marks first, because I've not run this part. So it says it doesn't know what is marks. So you run this, and now you say print marks. So now it will print the values 85, 88, and so on and so forth. Right? So you can see that 85, 88, 90, 76, 88, 80, 87, right? Or you could simply write marks. It will still show you on the console the value that marks contain. So this is again 85, 88, 90, 76, 88, 80, 87, right? Everybody following class?
Excuse me, sir. Sir, I asked something.
Yeah.
Sir, actually, sir, what is raw data? Actually, I haven't understood that type. What is
No, that type is not important. I told you. So don't. We have less time. Let's not waste much time on that. You will not use it anyway, right? Just because it is a type of data that is available, it is important academically, but it is not something that you need to really go into, right?
Okay.
So, and you can always Google out. So don't worry so much about it. You will not use it anyways, right? So coming back here, let's consider the vectors now. So marks equals to concatenate, and you can give a series of numbers here, and all of this would be then here, right? So this is now one data structure. Your marks in 7 subjects are now into a single object known as marks, right? Now you can check what is the class of marks. So you say class of marks. So this will come as numeric, right? Because the data type is numeric here, right?
Hello, sir.
Then, yeah.
Sorry to interrupt. Actually, I wanted to know what is meaning of a vector in R.
So I told you a vector is a collection of data set, right? So you have multiple 7 data combined into a single object, which is known as marks now, right? So this is what is a vector. Okay. The vector is the simplest data structure in R, which can hold similar type of, like when you give numbers, it will only hold numbers. It cannot have numbers and character together. It cannot have numbers or Boolean together. Only one type of data types, a collection of data types of one single type, can be held together in a single vector. You follow, everyone? Class?
Yes, sir.
Yes, sir.
That's emphatic, yes. Good. Okay. So, and I'll tell you what is the advantage of doing this, right? So we'll come to that. So here you are. You can check what is the class of marks. So this will be numeric. You know there are numbers in this. So this is numeric, which is fine. Then if you can check whether it is a vector or not. So you say is dot vector marks. If this is actually a vector, the value will be true. Otherwise, it will be false. So this is a Boolean that is going to come out of it, right? Or a logical. So this is true. Is dot matrix. Matrix is another data type in R. So we'll come to that in a later class, today itself. This is not a matrix, so this will be coming as false, right? And dimension of vector is null. The vector does not have any dimension. Remember that. A vector will not have a dimension. A matrix will have a dimension, and we'll see what dimensions matrix will have as we go along. Then you want to know what is the number of elements in your vector. So how many elements are there? 1, 2, 3, 4, 5, 6, and 7. So the command for that is length marks. You can say length marks and you can run it. This will give you 7, right? So you know how many numbers are there, right? Then let's say, so the question is, why do you do it into this? What is the advantage of declaring a vector here? So vector there are certain functions that can be performed on vectors. For example, you can say sum sum marks, sorry, not in capital. Remember, all languages are case sensitive. Sum, M-A-R-K-S, right? So when you say this will give you the sum of marks. Let's run this, right? 594. For our purpose, let's make it simple so that we are able to calculate. So let's say we are having only 5 here. So let's say we have 1, 2, 3, 4, 5, right? And let me run it one more time because otherwise the previous marks values will be there. So say run, right? Now let's say sum of this. So what will be the sum of this class? Quick. What will be the sum of this? Quick. 15. Very good. Aditya. Good. Great. So sum of marks will be run, right? So this is 15. Then you could apply what is known as mean of marks, MEA. What will be the mean? MEAN. 3, Lakshika, very good. Right? So you say, again, you run this, right? And you get 3. You could look for variants of marks, VAR and MARKF, right? So measures of central tendency and other statistical measures you can directly do here. VAR marks will give you a value of 2.5. Remember, it will be n minus 1 divided by n minus 1. The squares of difference with mean divided by n minus 1, right? And then you could also do standard error, SD, MARKS, right? And you can run this again, and this will give you, again, the standard error. So that is the advantage of organizing data into vector, right? Even when you do your other data structures, individual columns will be vectors only. And individual columns, again, you can apply your functions again like this. So that is why vectors become important, right? Now let's say you want
SD is what?
Standard deviation.
Okay, sir.
Standard deviation. I said standard error, I guess, right? Standard deviation. All right.
Can we run all together, sir, or not?
Sorry. Huh?
Can we run length, sum, means, words, SD?
Yeah. Select everything together and run it. Everything is running together, right? This is your previous run, and this is a new run. Okay. Let me give some enter here so that we know that we are into the new one. And let me run this again, right here. Where did we go? Hey, I didn't delete it, right? Anyways, so let's leave it. Maybe I deleted or what? Okay, let's move on. So now let's say you want to access the first element in the vector, right? So you want to know what is the first element in the vector. So the way is you write the vector name and then in square brackets 1, right? So you remember we have given 1, 2, 3, 4, 5. The first element would be 1, right? So you have 1. If you want to access the fifth element, you can say 5, right? And that would give you 5, right? So remember in R, the indexing is from 1. In other programming languages, the indexing is from 0. Like for Python, the indexing is from 0. If you want to access the first element of a list in Python, the command would be list name and in square brackets 0. In R, the indexing begins from 1. That is something that is important and you must remember, right? Okay, good, Lakshika. Okay, then you move on. You can also do what is a summary function. You can do summary marks and it will directly give you some of the major features of your vectors. So minimum, maximum, then the first quartile, median, and then the third quartile and the mean. All these values will be given to you, right? Then you can come back and you can, as I said, you can do total sum marks. And then if you want to print, you can print also. So here you are, right? So when you say print, because you're also printing a string alongside, you have to say print paste and then in round brackets first the string that will be printed as such, And then, of course, the variable into which you've calculated your total marks, which is basically total marks equals to sum marks, right? So this is again, and then average also you can calculate. I've already shown you how you can do that, just that the printing part. So you run again, and you get your average marks obtained equals to 3. Median marks we had not done, so median marks can also be calculated, right? So you can either equate it to a variable directly, or you could directly say median marks. Let's say you remove this the way we were doing earlier. So you can say directly here, and that would print your median marks directly. So you run, and your median marks are here. Then you could multiply your vector with each value of the vector multiplied by a particular number. For example, you want to say double the marks. So whatever marks are obtained, 1, 2, 3, 4, 5, you want to double them up. So you say double underscore marks equals to 2 asterisk marks. And before that, we print marks so that we have a reference. So you print marks, and then you double marks, and you then print double marks, right? So here you are, 2, 4, 6, 8, and 10, right? Then you could do a division of all the elements with a single number. So for example, your half marks, again, you'll get your original vector. So you say run marks by 2. So no, this will be half of the original vector. So this will be 0.5, 1, 1.5, 2.5, 2.5, right? Then you could also do a multiplication between two different vectors, right? So in case the vectors are of the same length, then it is position by position multiplication. So 1 into 4, 2 into 5, 3 into 6, right? So if you see here, you have one vector A equals to concatenate 1, 2, 3. You have the second vector B equals to concatenate 4, 5, and 6. And then you have AB equals to A asterisk B. So because they have the same length of the vector, position wise multiplication would happen. So you'll get 4, 10, and 18. So if you run this now, so here you are, you print your AB, run 4, 10, and 18, right? Everybody following? And you can see all your variables that are declaring here are also coming up here, right? So you can say, I didn't see the question. There was some question before Lakshika said yes, sir. The messages go off very fast. I'm just able to cursorily have a look. Somebody was asking some question, why to do this? Okay, so then we move on, and we again, likewise, you can do the division. So this will be 1 by 4, 0.25, 2 by 5 will be 0.4, 3 by 6 will be 0.5. So if you see here, you can AB div, and you can run this 0.25, 0.40, 0.50, right? So this is how you can do it. Individual elements, you know how to access that now. So you can write AB, and then you could write your rectangular brackets, and in brackets you could write whatever position you want to look at. You could also combine vectors. For example, you create a new vector Z, which is equivalent to combine A, B, and A. So the first all values of A will be there, then the values of B will be there, and then the values of A will be there again. So first let's print A again. So we run, this is A, this is B, and here is now Z, right? So you say print Z. So you run this here. So Z is first A, 1, 2, 3, then B, 4, 5, 6, then A again, 1, 2, 3. So you can combine vectors into a new vector by, again, using concatenate and giving the order in which you want to combine them together. Length of Z will be 9. So you know length is the command to see how many elements are there in the vector. So that is 9, right? Then you could also have character vectors, right? You cannot just have numeric vectors, you could also have character vectors. So remember, vector, the important property is that in vector, the important property is that you can only have one type of values. Either you'll have numerics, or you'll have characters, or you will have Boolean, or you'll have integers. It cannot have a numeric and a character together, right? So that is important. So for example, here I say my underscore name equals to concatenate, and I say my name is within, right? So this is my name. So you run this, and you get your vector values here. Then the class of my value, when you say run this, you have the class. This is character now, right? So this is character. And then you could have summary of my name. So this is not numeric, so you will not get measures of central tendency. Instead, you'll get what is there in each column. So when you say run this, you get length is 4, class is character, and mode is also character, right? So this is the summary, how summary command will work on character vector. Then you could also, let's say you declare something like this, where you say numbers equals to concatenate, and you give 1, and then you give 2 in character, then you give 3, then you give 4 in character, right? So anything in double quotes is a character. It's basically a string and a character, right? So you now do this, you run this. This is what you have. If you now check the class of numbers, it will be, what will it be? Character or numeric? Class of numbers will be? No, character. No, it will not be both. It cannot be, it cannot. So that is what? Vector cannot have both, right? So it will be character, right? Because you have included characters here, it will be character. So let's run this and see. This is character, okay? So if you have a single character vector, anything included in double quotes, that becomes a character vector, right? So there's no doubt about it. So why I'm showing this is important. So now let's say you pull out the first number, which is 1 from here. So you say num1 equals to numbers, and in square brackets you say 1. So you are running this, and then you are printing your num1. So it will be shown to you as number. So you say this is 1. But remember, this is coming in double quotes, right? So this is a string and not a numeric, right? So when you say class of num1, it will still show you as character, right? Because this is a character vector now. And if you want to add num1 plus 2, this is not possible when you say run this, because num1 is not numeric one, but a character one. So when you run this, it will give you an error. Num1 plus 2, non-numeric argument to binary operator, right? So this is important. It's both. Kanika, I only partly saw your question. The messages disappear very fast, right?
Sir, can I repeat over here?
Yeah, please do.
That numbers had both integers and characters. So why only character was picked as a class?
That is how the language has been written. Okay. So whenever you have a character in a vector, the entire vector becomes a character, right? It is individual elements of the vector become characters. They will not be numeric anymore. So that is how it has been defined in the language. Okay.
Thank you. Okay, thank you.
Hello.
So, yeah.
Sir, just 2-3 comments before you showed that accessing individual elements. That point I didn't understood. Can you please repeat?
Here you are. Let's see, you're wanting to now access the individual element here. Let's say you want to access the first element of the vector, right? So you say num1 equals to, and the name of the vector is numbers, and then you mention in square brackets which position you want to refer to. So you're looking at the first element. I told you in R, the indexing begins at 1. So the first element is at first position, second is at second position, third is at third position, so on and so forth. In Python, indexing begins at 0, right? So let's forget Python for now. So therefore, when you want to access the first element of a vector, you'll say the name of the vector, and you'll write in square brackets 1. That will give you the first element of the vector, and we're equating it to first one here, right? So this is how you access individual vectors here, and in this case, this will be still be a character because it contains some character vectors. So therefore, it is coming in double quotes. Okay, you followed?
Yes,
you
sir.
Followed?
Yes, sir.
Yeah, you can access, if you say 2 here, then you'll get TWO because that is your second character in the vector, right? So if you say num1 equals to number 2 and you run it again, and now you print num1, it will be TWO, right? So now, of course, you would have followed, right? So this is how it goes. So next, what happens is, so remember we were picking up number 1, right? So let me go back here, otherwise it will not run at the bottom here. So let me just rerun it and print out 1 here, right? So now we are trying to add num1 to 2, which is visibly 1, but it is not a number, it is a character. So therefore, this will not work unless I change the type of the data type. So I say as dot integer num1 plus 2, this will work, right? So now when you say run, this will give you a value of 3. So what I've said is num1, I want to use it as an integer instead of character, which is actually, when you extract it, it is a character, you change it to an integer. You follow everyone?
Excuse me, sir.
Right?
Yes,
Um,
sir.
Okay,
Yes,
good,
Yes, sir.
good.
Sir,
Yeah.
sir, in that number one, you said that that is a character one, but it
Yeah.
can be, I think so, it is not in double quotes mentioned, so it can be that in numeric one. I think so, sir.
No. So that is why I'm showing you all this. See, you follow what is being told to you. I'm telling you, when you do a num1 plus 2, had it been numeric, it would not have given you an error, right? And I've already shown you this is a character. Num1, class num1, it is a character, right? So follow everything properly.
It is, nee, that is showing, but when it is in double quotes only, then it is a character. I think so. That's why I was.
No. That is what I'm telling you. Even if you have a single element that is in double quotes, the entire vector becomes a character vector. Every single element of the vector becomes a character
We
vector.
have kind
You
of
follow?
okay. Matlab in vector we have some kind of thing over here.
Yeah, so in vector, whenever you have a single element that is in double quotes, then everything becomes a character vector. Every individual element of the vector becomes a character. Okay?
Sir, when I did num1 plus 2, it is giving an error when I'm using as dot integer.
It should not give you an error, right? You must not be doing it properly. It is not possible.
Okay.
I mean, I'm showing you here itself, right? So that is not possible. There must be some problem with how you're declaring it.
Okay.
Okay. So then we move on and we talk more about here. What is that? Non-numeric to binary. Why is that coming? Num1 plus 2. Okay, so this one. You say as dot integer num1 plus 2, and this will work out fine. Right? This will work out fine. It should not be a problem. Are you giving it exactly this way? As dot integer and in round brackets num1 plus 2. I mean, you would have, I was talking to whom? Anyways,
Yes, sir.
let's move. If you give it this way, it will not show an error, right? And if you want, you can send me a snapshot to my WhatsApp number. I'll tell you where the problem is.
Okay,
Right?
sir. Okay,
So
sure.
that is okay. If that is okay with you. Okay.
Okay, sir.
So let's now move on to, so you could also have what is known as a named vector. So you can say named vector is like named underscore vector equals to combine or concatenate. A equals to 11, B equals to 2, C equals to weapon, right? So this is again your named vector and you can run it. And then of course you can pull it out with the name of the vector, right? So you can say names, named vector. That will give you the names of the named vector A, B, and C. And you could pull out the individual elements with the help of, instead of the position now, you're giving the name index, right? So I'm pulling out named vector and the index I'm giving is A, right? And when you say A, I'll get 11, right? So this is what is your named vector, right? So we can stop with vectors here and we can move on and we can talk more about other data structures, right? We have 2 more to go. We'll do a bit today and a bit tomorrow, and then we'll do a bit more on how to use these in the analysis, right? So we'll stop here. Let me save this. So you can save this here and we can stop it here, right? And then we come back to our data structures, right? The other way of declaring a vector is this, where you can say, we can say v equals to, and we can say equal to, or this is the earlier way of assigning values. So we can say v is equal to 5 is to 30. So we will have values from 5 to 30. You say run, and you'll have v equal to this. So you can say print length of v, right? And then you could also print v. So we can say print, print v, right? So you can also print v. So this is basically giving you values from 5 to 13. So whatever is your is2, starting from the first letter until the last number, that is what it will be. So you're generating a number series using the is2 notation. So this is also a vector. Then you can say print the dimension of V. What is the dimension of a vector class? Anyone?
It is dimensionless.
Asta says null. Very good. Very good. So dimension of vector is null. Okay. Good. Dimensionless, Bhavya. Okay, good. Bhavya. And Shiv Sankar joined. Okay. And then, of course, you could have, you could also say V is equal to 3.5 is to 11.4. So it will have values from, so we can say print V first, print V, and see what comes here, say run, and you'll have values from 3.5, 4.5, 5.5. So this will be separated by 1. Because the last is 11.4, you'll have the last value as 10.5, right? So this is another notation where you can have your values with a difference of 1 until the last value, which will be, if it was 11.5, then it would have been 11.5, but because 11.5 is more than 11.4, so it stops here. You can say print V8, so this will be your 10.5. The last one is here, right? Then you could also generate a sequence by using the sec command. You could say print sec 5,7 and by equal to 0.5. So it will start from 5, 5.5, 6, 6.5, 7, and that should be where it ends. So you say run, and you can say print. You're already printing anyways, right? So you're already printing. So this is 5, 5.5, 6.0, 6.5, 7.0. So this is basically, I'm telling you what are the other ways of generating a vector, right? And you can do that. Then here in this case, let's say you are having two vectors, V1 and V2. One is 3 elements, the other is 2 elements. So when you sum that out, how does the sum happen? Remember, when you had equal length, you could simply 3 plus 4 would be 7, 8 plus 11 would be 19. But here in this case, you have another element in V1, but you do not have the same element in V2. So what will happen is this will be repeated. So it will be 4, 11, and then 4 again, right? So it will be 8. So if you see here, when you sum them up, add V1 plus V2, you get, it gives you a message and it still gives you the addition. So you say r dot result. So you say run here, 7, 19. So 7 and 19 is okay. First position, second position. For the third position, where the second vector is shorter in length, it will be repeated again for the third position. So starting from 4 again, right? So 4 plus 4 will be 8. Had there been one more here, let's say you have one more here, so then it would be 11 plus 1, right? So if you run this now, this will be 7, 19, 8, and 12, right? And then you can print again. 7,
Hello?
19, 8, 12. Yeah.
Sir, can you please repeat V1 and V2 part?
Yeah. So what I'm telling you is, what is happening here is V1 has 4 elements, V2 has 2 elements only, right? So what would happen is this will be, the second vector will be iterated again. So for example, for this position, you'll have, so basically what effectively it is doing is it is making it like this. The two positions will be repeated again, 4, 11. So now it is easy to see what is the addition. 4 plus 3, 7, 8 plus 11, 19, 4 plus 4, 8, and 1 plus 11, 12. So this is what is happening here, right? So the shorter vector will be repeated for the positions where it is falling short in the same order, right? So 4, 11, 4, 11. If this was only this, then the third position was missing, so it would be 4, 11. So it will be only 4 now, right? So it will be 4, 11, 4 for that matter. So basically 4, 11, 4, 11, 4, 11, 4, 11 till the time it matches to the length of the longer vector. Everybody following?
Yes, sir.
Yes, sir.
Simple.
Yes,
It's
sir.
not very complicated. Yeah, good. That's enough.
Only in the longer one till it's longer.
Yeah,
adding.
till it is equivalent in length to the longer vector, it will keep adding the original values on, right? So 4, 11, because there is only one deficit, so now it just repeats 4 again. If it was again, as I showed you, it was, let's say, again 1, so it will be Again, 2 deficits, so it will be 4, 11 again. So this is effectively how it is treating the vector, the second vector now, right? If there was one more value here, 5, let's say the fifth value is 5. So again, you will have comma 411. So 411, 411, 411, 411 till the time it matches the length of the longer vector, right? So that is what it is doing. I hope now that should be clear, right? Now let's have this here. So if you see, again, I'm giving you a vector. So vector is DNA, RNA, 1, 2, and you say run, and then you're printing the type of V, and this should be character again. So once you have anything with double quotes in your vector, all values in the vector become characters, right? You could, let's say, and even if you just have 1, 2 and 1, 2 is put in double quotes, that also would become a character. Now let's move on to the second data type, and that is your matrix, right? So matrix, as you know, it is basically a tabular data and it has columns and rows, right? So let's say we have a vector here. So we say this is your vector, and we are basically making a matrix of 3 row and 3 column. So we say matrix 1 is equal to, the keyword is matrix, right? And what is the matrix values? This is basically a vector which is being converted into a matrix. So the vector is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we say that converted into a matrix of rows, which is equivalent to 3. So this is the format in which you can convert a vector into a matrix, right? So you declare your vector. We could also have done it, an easier way would have been, so let's say you say VEC vector 1 is equal to, and you say combine, and you say 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you have already declared your vector, and then here you say, instead of writing the entire vector values, you say VEC TOR vector 1, right? And then you define the number of rows you want, because this is 9, so you automatically get the columns as 9, right? So you say here, you can run this now. Sorry, so we have not defined the vector first. So first we have to run the vector, okay? You run the vector, and now you say matrix 1 is equals to matrix, which is the keyword to define that your data structure is matrix. And what is the value in matrix? The value in matrix is coming from vector 1. And how many rows? 3 rows. And you say run. And now you can print your matrix 1. So you print your matrix 1. You say run. Here is your matrix. Everybody here, class?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. So this is a matrix, right? So how have we created a matrix? First, we defined a vector. The vector had 9 values. And then we put this vector into matrix command, and we defined our number of rows, right? We could also say ncol equals to 3, but it is because n row is 3, we have 9 values, so ncol automatically becomes 3, right? And you say matrix 1. Now you say the dimension of matrix. The dimension of matrix will be the number of rows and columns. So you have run, and you have 3 by 3. Remember, in matrix, always the row will come first and the column will come second, right? Then if you see here, how have we arranged the matrix? So here, if you see, we had the values 1, 2, 3. So 1, 2, 3 have come in columns, 4, 5, 6 in the next, 7, 8, 9 in the next, right? So this is one way of, when you do not define how you want to arrange your matrix from a vector, it will by default arrange column wise. The first value will into the first column, then the second value, second column, then the third column, then move on to the next column, and then the third column. Now let's say we want to define that we want the arrangement of values by row, right? So you can say for the same thing here, matrix 1 equals to matrix, then concatenate the values, which is basically your vector C1, 2, 3, 4, 5, 6, 7, 8, 9, n row equals to 3, and you want to arrange them by row now. So by row equals to true. If you don't mention this, it will be arranged by column. When you say by row equals to true, now what will happen is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the values will be arranged, values of the vector will be arranged in the matrix by row, right? So let me just show you here so that you follow it better. You say run. And here you are. You can see the difference between the two matrices. These are transpose of each other, right? So 1, 2, 3, this is column wise, this is row wise. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And 1, 5, 9 positions will still be the same. 1, 5, and 9 will not change, right? Everybody here, class?
Yes,
Okay, got it. Okay, good. So because I'm a teacher, I keep taking feedback from the students as we move along. Otherwise, it seems like teaching to a wall, right? So now how do you access individual values in a matrix, right? So you can, again, because matrix, any value would have an address of a row and a column. So you have to define it in two coordinates. So you say print matrix 1, 2, 2. So matrix 1 now is arranged by row. So here, if you see, so 2, 2 will be this one, right? 2, 2 will be 5, right? So if you say run here, 2, 2 is 5. 2, 3, row comes first, column comes later, right? So second row, third column, that will be 6. Lakshika is quick, always quick, right? Very good. So that is 6, right? Then if you want to see all values in the second column, right? So you can say print matrix, open the square bracket, before comma, do not give any value, and then give the second column, give the value of the column that you want to look at, right? So when you say this here, this will give you the values of the second column. So second column is 2, 5, and 8, right? So you run this and you get 2, 5, and 8, right? This is giving you second column now. So all values in the second column, and this is a vector in itself, right? If you equate it to, let's say you say A is equal to, so this will be a vector in itself, right? So if you say A equals to print this one, and then you say here, right? So this is 2, 5, and 8. Likewise, if you want to look at all values in a row now, so again, you're saying print matrix 1, 2, and then after comma, you don't give any value. So now it will print all values of second row. What will be these values, class? Anyone? Quick. Let me show you the matrix here. Very good. So Lakshika says 4, 5, 6. Karnika says, and in between somebody else said, I missed that, but I could see 2 people. So that is right. So which is good. So if you say print here and you say run, 4, 5, and 6, right? Yogita and Neha and everybody says, okay, good. So this messages they just come for a moment and they just go with. Sometimes I'm not able to catch them as fast. Then you could have a special class that is known as list, right? Which is again a data structure where you can have any type of data combined together. You could have a vector, you could have a character vector, you could have a numeric, you could have a Boolean and everything, right? For example, here in this case, you have here list 1, list equals to, first you have a vector, this is 4666, right? Then you have a vector for restriction enzymes, 1, 2, 3, and 4. And then you have a vector for the recognition sequence for each of these restriction enzymes, right? So this 4666 is the length of the recognition sequence. How many of you are from the biology background? Of course, everybody, genomics, right? So you're doing the genomics workshops, yeah. Everybody must be from biology background. So I'm sure you understand what is a restriction enzyme or something, right? So here you are. So list basically is this, and how to access individual elements in a list. So let's say you want to access the third vector in the list, which is this one here. So you'll have to say list, and then in double round brackets, you mention 3, right? So this will give you CCGG, GAATTC. Let's see what this gives. So first, let me run the first part. Run. Right, and then let me list 3, right? So this is your list 3. All right, so here you are. So this is list. So list is where you can have different data types in the one single data structure, right? And this is the same also for data frames, which will be the final data types that will do, and which is the major data type that we deal with when you do your biological analysis. So tomorrow we'll do data frames in more details. This is just to give you an idea of things. So you have this one here. So list1 is equal to list1 is to 5. So you say run, and then you can say print list1, right? So you say run 1, 2, 3, 4, 5. This will be in the first itself, right? And then if you want to convert a list into a vector, you can say unlist. So list2 equals to unlist list1, right? So you say run, and now it becomes a vector. So list2 is a vector now. So we say print list2, and you'll have these values 1, 2, 3, 4, 5. It will not come in this notation. So this is, when you have this notation, it is basically a list. And this one here is a vector, right? And you can check also. So you can say is dot vector list2, and that should come to true. Is dot vector list2, and you can say run here, and you can see this is come as true. So now when you unlist, a list becomes a vector, right? And sometimes you would require to do this in your actual programming, right? So we have done the basic data types. Tomorrow we can begin with data structures, and then of course we could do a bit of deployer and other things, and that should take care of our 2 lectures is a little less for our, but then we'll try and cover as much as possible, right?
So can you repeat the unlist part once again, please?
Yes, yes. So what is a list? List will have a lot of characters and of many different types. If you want to convert it into a vector, you can say unlist, right? So list. So for example, here we had a list which had only numerics, right? So list 1 is to 5. So this has 1, 2, 3, 4, 5 is the values that you have here. You can print the list, right? You say run, and you can see this is coming in typically double brackets first, and then it is giving you the values 1, 2, 3, 4, 5. So this is a list. There is no point of keeping it in a list because it is all the same type of values, numerics. So you can convert it to a vector. So for that, you can say unlist. When you unlist a list, it becomes a vector, right? So that is the whole idea.
Okay,
So,
thank you, sir. Thank you so much.
Yeah. So you run it, and it becomes a vector now. You can see whether list2 is a vector or not by saying is dot vector equals to is dot vector list2. This should return a boolean true or false. So you say run this, and this returns a true, right? So that is what is to show this. And then one more thing that you can do is, and we can basically discuss that as what is known as how to set up the working directory. So when you open your R, you will be by default into a certain folder, right? So you can see where you are in your R studio by saying get wd. Yeah.
Sir, you said that list one, sorry, that is converted into a vector one. So the output too is getting the same kind of thing, I think so.
Output 2? Yeah, it will still have the same values, right? Values won't change. Nature of data type, the nature of data structure is changing. The values will still be the same.
So how we can differentiate vector and list over in this? Actually, that I'm thinking it is showing the same thing.
That is the whole idea. A list can contain not just numeric, it can also contain characters, it can also contain Boolean, right? That is the advantage of list. List can have multiple data types in one single collection, right? You get the point?
Actually,
Okay.
sorry, sir.
Vector can only support one type of data type, either character or numeric. List can support all the different types of data types together.
So that is fine, but actually the output we are getting, how we can differentiate?
Output will still be the same, बेटा. उसी को तो change कर रहे हैं ना आप. Output थोड़ी ना बदलेगा. 1, 2, 3, 4, 5 में change नहीं कर रहे. You're only changing the data type. Okay.
So list and vector.
You read a little more. If you don't understand, then we'll talk about it tomorrow again, right? Okay. So let me not miss this point here. So what you're saying, what I was telling you was when you open your R Studio, you would be into a certain working directory, right? So you can check which working directory you are in by giving your command get wd, right? So you say get wd, and let's say you run this. So you'll know where I am in my system right now. Run. I am in dpython, right? Okay. So now if I want to access a file which is in my E folder, and let's say R human genome, either I have to give the full file name, file path, otherwise I'll not be able to open that file because I'm not in that folder right now. So I can set my working directory to the folder I want it to. So I say set wd, set wd, set working directory, and I can define where I want my working directory to be. So I can say E, and then I can say, I think colon will be required, and then you can say which path. So let's say we want to go to a folder in E. In E, I want to go to, let's say we want to go to Galaxy, right? So let's go to Galaxy. Galaxy, right? And you say this one here, and you say run. Now I'm in my eGalaxy. How do I know I'm in my eGalaxy? Because I've not got any error. So you can say again, get wd and no arguments in brackets, and you press enter and you run this. I'm in eGalaxy. Can you see that class, everyone?
Yes, sir.
Everyone around.
Yes.
And
Yes.
because you're using RStudio, you can do it here as well, right? You can go to, where do you go here? You can go to session. You can say set working directory. And then you can choose directory from here. It will take you to your computer folder. You can go to F, and in F you can go to, let's say, molecular genetics, right? And you say open, right? Now I say get WD, I will be in F molecular genetics. GET, WD, enter, and I run this again. I could have run the earlier one also. I'm in F molecular genetics. So how do you go there? One is through the command line. The other way is through session, set working directory, choose directories. So wherever you want to go. So what is the advantage of this is that let's say now I want to select a file in this folder, index folder. So I don't have to define my file path, right? I can directly say open and file name. I'm already in that folder, so therefore the file will be opened directly. So this is one common concept in all programming languages, which you should know. So I'm just showing you here. So I think we are 6 minutes past 8, so we can stop here for today. I hope you all have learned, and for this list thing, again, I'm telling you, it is a very simple thing. We have just converted it from one data type to another data type. The values of the data will not change. Okay, that is what you're insisting, that the value is still the same 1, 2, 3, 4, 5. The value
Actually,
will still be the
sir,
same. Yeah.
Sir, I got that one. Actually, that was represented in bracket one. That is the
Yeah.
output I wanted to do.
Yeah.
That
Yeah.
and vector is not represented in bracket. That is the thing.
Okay. Yeah. Yeah.
Fine. Thank you so much.
Yeah. No problem. Yeah. Arpita.
Excuse me, sir.